Hey, welcome back to Minute Science Marvels, where we tackle big science concepts in under 15 minutes. Last week, we explored exoplanets, which are real-life sci-fi worlds that orbit distant stars. A few weeks ago, we also explored quantum computing, and both topics kind of spark questions about the nature of reality and what might exist beyond what we can observe. But what if I told you there could be an infinite number of versions of our universe? Different worlds, different realities, maybe even different versions of you. This week, we're diving into the multiverse. From Marvel movies to quantum mechanics, the idea of multiple universes has captured imaginations for decades. But is there real science behind it, or is it just a cool idea from sci-fi? Today, we'll explore what the multiverse is and how scientists define it, the theories in physics that might explain it, and why it matters and how it could change our entire understanding of everything. Let's get started. So first, what exactly is the multiverse? It's the idea that our universe isn't the only one. Instead, it's a part of a much larger system of possible, maybe infinite universes. These universes could have completely different properties, from their physical laws to their timelines, and some could be even eerily similar to our own. Scientists have proposed several ways that the multiverse might exist, but there are three major theories. We'll go more into depth with them when we discuss the science behind them. First, there's bubble universes, or cosmic inflation. Right after the Big Bang, the universe expanded at an incredible speed in a process called cosmic inflation. Some physicists believe that inflation never fully stopped, just different regions of space stopped inflating at different times, which formed some isolated bubbles. The key idea is that each bubble could be its own universe, with its own unique physical laws and its own constants. Some could have different strengths of gravity, different numbers of dimensions, or even totally different forms of matter. Imagine like a literal bubble bath. Each bubble is a separate universe. They all float alongside each other, but they don't really interact. Some might pop, some might merge, and some might still be forming. Another theory is the quantum many worlds interpretation. Quantum mechanics is one of the most successful but bizarre areas of physics. It suggests that particles don't have definite properties until they're actually observed. Instead, they exist in multiple states simultaneously. This is called superposition. The key idea here is that according to the many worlds interpretation, rather than reality choosing a single outcome when it's observed, the universe splits into multiple parallel versions, one for each possibility. If you think of a decision tree, every time you make a choice, another version of you branches off into a different reality, making a different decision. Right now, there could be a universe where you're watching this video, one where you're on the audio version, one where you're asleep instead, one where you're at McDonald's, even one where you never found this video. And all of those branches keep expanding indefinitely. Last but not least, there's Brane Theory or String Theory. For those listening to the audio version, it's Brane. From string theory, this suggests that our universe is like a brane or a floating sheet of space in a higher dimensional space that we can't quite perceive. Other branes could be parallel universes that exist right next to ours. They're invisible, but they're incredibly close. The key idea in this one is that the space between these branes is called the bulk, and that's what might contain extra dimensions that allow them to exist separately. Here, the Big Bang itself might have been caused by two branes that collided, resulting in an enormous amount of energy and creating our universe. For this one, imagine slices of bread in a loaf. They're all stacked on top of each other. Each slice represents a different universe, separate but existing alongside the others. They don't really combine or anything, but if they did, it could cause something as massive as the Big Bang. So there's bubble universes, many worlds interpretation, and brane theory. In movies like Doctor Strange and the Multiverse of Madness and Everything Everywhere All at Once, they bring these concepts to life through alternate realities and wild visuals. But how much of this is actually science? Let's find out. Is there real scientific proof for the multiverse? The short answer, maybe. While we don't have direct evidence yet, some of the most well-supported theories in physics naturally predict the existence of multiple universes. Let's go beyond speculation and look at the actual scientific studies, experiments, and observations that suggest that the multiverse is a real possibility. Let's start with cosmic inflation and the bubble universes. The inflationary model of the Big Bang suggests that right after the universe was born, space was expanding exponentially fast. But what if inflation didn't happen everywhere at the same time? In this scenario, some regions of space stopped inflating, forming bubble universes, while others continued to expand. One key finding here is from the Planck satellite. This was a mission from the European Space Agency. In 2018, it detected anomalies in the cosmic microwave background, or the CMB, which some physicists think could be the scars from our universe colliding with another bubble. There was also BICEP 2, which was a telescope experiment located at the South Pole, which was operated by the Harvard-Smithsonian Center for Astrophysics. In 2014, it initially reported the detection of primordial gravitational waves, ripples from the early universe that could support theories of inflation. Later analysis suggested that the signal might have been influenced by cosmic dust, but the search continues. Overall, bubble universes are predicted by inflation, but we still need more observational evidence to confirm them. Now, for the many worlds interpretation of quantum mechanics describes how particles behave at the smallest scales. And it turns out reality at this level is weird. One of the most famous quantum experiments is the double slit experiment, where particles like electrons act like waves that pass through two slits at the same time until they're observed. When they're observed, the wave collapses into a single outcome. The many worlds interpretation suggests that rather than the wave collapsing, all of the possible outcomes happen, just in separate parallel universes. The key study here is Hugh Everett's 1957 paper, which is The Theory of the Universal Wave Function, which introduced the many worlds interpretation, suggesting that all quantum possibilities exist simultaneously but in separate realities. Some supporting evidence is quantum decoherence by Zurich in 1991, which explains why we don't perceive other worlds. They split so cleanly that they can't interact. Also, IBM's 2002 quantum experiments observed particles in multiple states, which aligned with the many worlds interpretations model. Some physicists also speculate that quantum computing, such as Google's Sycamore or Willow, could indirectly support the many worlds interpretation. Since quantum computers have to process multiple possibilities at once before resolving in a final answer, this kind of aligns with the idea that all outcomes have to exist in parallel before decoherence selects one. However, this remains a theoretical connection rather than direct proof. The challenge here is that it is mathematically consistent, but currently untestable. Since we can't really interact with these other parallel worlds, it remains just an interpretation and not direct proof of the multiverse. Last but not least, there's string theory and brane universes. String theory attempts to unify quantum mechanics and general relativity. But to work, it requires extra dimensions beyond the three that we can see. One version, Brane Theory, suggests that our universe is a 3D membrane, that's where brane comes from, floating in a higher dimensional space, which is called the bulk. One key study here is the ekpyrotic universe theory, which was proposed by Khoury and his colleagues in 2001. They proposed that the Big Bang was caused by two branes that collided. Cosmic string studies done by Sarangi and Tai in 2002 suggest that cosmic strings are one-dimensional energy defects that could be evidence of brane interactions. The challenge with this one is that mathematically it's promising, but it's another one that hasn't been able to be experimentally tested. To make this even more confusing, some researchers believe that black holes could be portals to other universes. The key studies here are Stephen Hawking's 1974 work on black hole radiation, which suggested that the information entering a black hole might not be destroyed, but instead it's leaked into another reality. Also, there's the 2020 study in Physical Review Letters that explored the idea that black holes could connect different regions of space-time, maybe even different universes. After the black hole video, I got a few messages about how terrifying black holes are. But imagine them not destroying you. Imagine it can spit you out into a completely different universe. Maybe it's a universe where Berserk is actually finished. That'd be awesome. But anyway, in conclusion, while we haven't proven the multiverse exists, major theories in quantum mechanics, cosmology, and string theory naturally predict it. Cosmic inflation suggests that new bubble universes are constantly forming. The many worlds interpretation explains quantum uncertainty with an infinite amount of parallel universes, while string theory and brane models propose higher dimensional universes existing right alongside our own. So, what's next? Scientists are looking for more evidence, like better gravitational wave measurements, cosmic string detections, and new insights into black holes. Until then, the multiverse remains one of science's biggest unanswered questions. Okay, so the multiverse sounds cool, but why does it matter? What's the real-world impact of actually studying it? First, it changes our place in the universe. If the multiverse is real, it means that our universe isn't unique. There could be countless other worlds, some with physical laws that are completely different from ours, and it challenges the idea that our universe is special or one of a kind. The big question this raises is, if there are infinite universes, how rare is life? And are we actually alone? It could also solve big questions in physics. The multiverse could explain why our universe's physical constraints, like gravity or the speed of light, are so perfectly tuned for life. In a multiverse, different universes have different constants, so we just happen to live in one where life is possible. Imagine if you're rolling dice. Our universe rolled just the right combination for atoms, stars, and planets to form. But in a multiverse, every possible combination has to be rolled somewhere. Another reason it matters is because it drives technological innovation. Theories like quantum mechanics and string theory, which support the multiverse, have already led to breakthroughs like quantum computing. As we explore these concepts further, we could see new discoveries in technology, space travel, and even AI, artificial intelligence. Again, one of the most important things, it captures our imagination. The multiverse isn't just a physics concept, it's inspired countless books, movies, and stories. It pushes us to think bigger, challenge assumptions, and imagine what might lie beyond what we can currently understand. And it's just plain fun to think about. If the multiverse is real, there's likely a version of you living on a planet where dinosaurs never went extinct. Maybe they're even the dominant species. Or maybe you ended up in a universe like Rick and Morty's Cronenberg world, where everything just went horribly wrong and now you're just trying to survive in a nightmare reality. Either way, let's hope we landed in one of the good ones. All right, that felt like information overload, but we finally made it through. On to our recap. The multiverse is one of the most fascinating and mind-bending ideas in science. It suggests that our universe is just one of many, possibly infinite realities, each with its own unique properties. Scientists have proposed three main theories: bubble universes, which come from cosmic inflation, where new universes constantly form like bubbles in a vast cosmic bath. Each bubble has its own laws of physics, and some might collide with others. There's the many worlds interpretation of quantum mechanics, which suggests that every decision or random event causes reality to split into parallel timelines. If this is true, there could be countless versions of you, each living out different possibilities. Brane theory from string theory suggests that our universe is like a sheet floating in a higher dimensional space. There could be other universes that are stacked closely together, possibly interacting or even colliding, causing massive cosmic events like the Big Bang. While we don't have definitive proof, hints in physics suggest the multiverse is a real scientific possibility. Some physicists believe that anomalies in the cosmic microwave background could be evidence of bubble universe collisions, while others speculate that black holes could be gateways to completely alternate realities. If the multiverse is real, it could completely change how we view reality. It challenges our understanding of space, time, and of existence itself. It could also explain some of the biggest questions in physics, like why the laws of nature seem so perfectly tuned to life. And even beyond science, the multiverse captures our imaginations. It's inspired countless of books, movies, and theories about alternate realities, time travels, and infinite possibilities. If there are infinite universes, then somewhere out there, another version of you might be watching the same episode with slightly different details. But what do you think? Is the multiverse just science fiction, or could it be science fact? Let me know your thoughts in the comments, and don't forget to like, subscribe, follow Minute Science Marvels for some more deep dives into the wonders of the universe. I will see you guys next Thursday. Have a great weekend.